Here is our learning target for today. I can simplify trigonometric functions. This is different from our previous learning target because previously our learning target is I can simplify basic trig functions. So now we are moving up in our understanding. First things first, you're going to fill up the top of your organizer notes with your 3 trig identities that you should know. There's just 1, 2, 3. And then we also have the reciprocal identities that you should also know. Cosecant is defined as 1 over sine. Secant is defined as 1 over cosine. We have tangent, that's defined as sine over cosine. And cotangent is cosine over sine. You should have these filled out in your notes. Feel free to pause the video. Alright, so this organizer is broken up into the strategy right here, an example, and what approach, what skills do we use is over here. As you can see, I already have some filled out. I'm going to be using the flip and multiply rule. I'll be canceling out terms, and I'm going to be using the tangent and secant definitions. So basically, this is like me looking at my notes, refreshing myself on my identities and my reciprocal identities. All right, this strategy is called rewriting in terms of sines and cosines. So that's exactly what it sounds like. This tangent right here, I'm going to rewrite in terms of sines and cosines. That means I'm going to rewrite this as sine over cosine. This secant right here, I'm going to rewrite as 1 over cosine. So this is the approach I'm using right here. So you want to fill this out in your notes right now. Let's go ahead and substitute these into here. All right, good. So now I rewrote tangent as sine over cosine. I rewrote secant as 1 over cosine again because I'm referencing my notes. Next, what I'm going to use is the flip and multiply rule. Whenever you have a fraction divided by another fraction, you take the bottom, flip it, and multiply across. This is actually going to be a very nice example because the cosine from the bottom will cancel from the cosine from the top. So then at the top, you'll be left over with sine, the bottom over 1. Sine over 1 is basically equal to sine. And that is it. You are done with strategy 1. Basically, this right here simplifies to sine. Here's your next strategy. That is the factoring technique. Before we move on to the factoring technique, this is what I'll be looking at to refresh myself on my identities. And my approach right here, I'm going to be factoring out the common factor. Then I'll be using this identity, but not exactly this one. So let's first go on to our first step. I see that there's a cosine here and a cosine here. So what I'm going to do is factor out that common cosine. But then what I have left over is 1 minus, and then I'm left over with sine squared. I look right here in my trig identities, I don't see one that says 1 minus sine squared. I see a 1 right here and I see sine squared, but I don't see 1 minus sine squared. So actually what I'm going to do is I'm going to take this equation, the first Pythagorean identity, and I'm going to rearrange it. What that means is, what if I subtract sine squared? So this is my first Pythagorean identity. What if I subtracted this from both sides so that I can get 1 minus sine squared? Yes, I subtract sine squared from both sides. Right here, this cancels out. On the left, you have cosine squared, and on the right, you're going to have 1 minus sine squared. So as you can see, I didn't have 1 minus sine squared on here, but if I took the first Pythagorean identity and I tried to solve for cosine, you get cosine squared is equal to 1 minus squared. So this right here is equal to simply cosine squared. So basically it's like I created a new identity. This right here is red, it's the same cosine. This right here became this right here. Alright, so we have 2 cosines right here, multiply with another cosine on the outside. We in total have 3 cosines. That's it. So we use factoring to reduce this into a smaller component. In our task, we might have this identity where you have to use 1 minus sine squared. That's why having your notes right by you is very important. Oh yes, lastly, I did use the technique that we have to add the exponents together when you multiply expressions with the same base. The third technique is getting a common denominator. Again, I have my identities that I'm looking at, and I also have my reciprocal identities. Alright, so getting a common denominator might be the one that requires the most work. Before I start getting a common denominator, my first step is to rewrite everything in sines and cosines. This one is already in sine, so we're good. This one is already in cosine, so we're good. Cotangent is not in sine or cosine, so what we're going to do is look at my reciprocal identities and rewrite cotangent as cosine over sine. So this cotangent is going to be cosine over sine. So then, to combine these, cosine is just going to multiply to cosine to get cosine squared. Next, we want to make sure that we can add these two denominators, so I'm going to put this over 1. And then I'm going to multiply the top and bottom by sine theta. That is because we want to have a common denominator so that we can add these two. So I multiply top and bottom by sine right here. Sine times sine will give me sine squared. The bottom is 1 times sine. That's just going to give me sine. Good. Now that I have a common denominator, I'm going to go ahead and add up the numerators. Sine squared plus cosine squared all over sine theta. Luckily, this right here is a nice identity because we know that sine squared plus cosine squared, if we look at my first identity right here, is equivalent to 1. Good, so we have 1 all over sine theta, but 1 over sine theta is equal to something. 1 over sine theta is equal to cosecant theta. So actually we are done. We simplified this right here into cosecant. Let me go ahead and fill in the approach that we just used. Let's go ahead and reflect what we just did. Step 1, the first thing I noticed was that cotangent was not in sines and cosines. So what I did is I rewrote it using my reciprocal identities. So cosine over sine. I got a common denominator, and I used the identity cosine squared plus sine squared equals 1 right here when I converted to 1. Lastly, I used the fact that cosecant is equal to 1 over sine to get this. So this was my approach in this problem. Here is the last technique, splitting one fraction into two fractions. Here I have my reference. So before I start to try, usually my step 1 is to rewrite in sines and cosines. But for this example, before I try to rewrite this secant right here into cosines, because secant is 1 over cosine, before I do that, I want to actually split up this fraction. So this is how that looks like. Basically, since this is divided to this term and this term, we can rewrite it like so. And because there's a minus here, that's why there's a minus. Alright, so when I rewrote it like this, secant divided by secant, remember anything divided by itself is equivalent to 1. So this becomes 1, and then we have minus cosine over secant. So let me go ahead and write what we just have. So again, this became 1, this I'm just rewriting, great. Now that I have it like that, I could go ahead and now analyze which ones I could rewrite as sines and cosines. So 1, we don't have to worry about. Cosine is already in cosine. Secant is not in sines and cosines. So what I'm going to do is go over here, and I'm going to see my definition for secant is 1 over cosine. So this right here is going to become 1 over cosine. Alright, so let's just, again, let's ignore this 1 minus for now. I'm going to look right here. So again, we have a fraction divided by another fraction, or whenever you have a fraction in your denominator position, you're going to be using the flip and multiply rule. So what we're going to do in this next step is take this, flip it, and multiply. Alright, now that we have it like this, cosine times cosine Since we have two of them, it's going to give us cosine squared all over 1. Cosine squared all over 1 is just cosine squared. So this right here became cosine squared. This 1 minus came down. Good. So 1 minus cosine squared, if I subtract cosine squared from this first identity, I'm going to get a new identity. So here we have that this part gave us cosine squared. That's this part. And now what I'm going to do, see this right here? If I use my first identity, if I subtract cosine from both sides, I get that sine squared theta is equal to 1 minus cosine theta. So basically, it's like we created a new identity using the first identity. So basically, 1 minus cosine squared theta is equal to sine squared. So that's what I'm going to rewrite. There we go. So now we finally reduced this into this last term. There you go. So feel free to pause this video and try to fill in what you can. And then we're going to be doing example problems based on these differing techniques.